mencapai misi yang satu, permisi kita bantu.
Tahniah, siaran langsung ini dibawakan khas kepada anda oleh Akademi Youtuber Malaysia. Tumpukan perhatian anda, siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Hai semua, Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera, selamat malam dan salam Malaysia Madani. Selamat datang kami ucapkan kepada semua penonton, khususnya guru-guru, ibu bapa dan pelajar-pelajar yang kita kasihi sekalian di mana jua anda berada. Kami doakan anda sentiasa sihat walafiat. Okay, so malam ini sekali lagi kita bersama dengan kelas tuition PERCUMA yang dibawakan khas oleh Akademi Youtuber Malaysia dengan kerjasama E-Didik Malaysia dan Kelab Guru Malaysia. InsyaAllah kita akan bersiaran selama lebih kurang 1 jam bersama dengan presenter kita iaitu Mr. Peh. Akan saya perkenalkan nanti dengan tajuk kita Fizik Tingkatan 5 DLP iaitu tajuk yang kedua 1.2 Resolution of Force. Jadi seperti biasa sebelum kita mulakan kelas pada malam ini yang beragama Islam, marilah kita mulakan dengan Ummul Kitab Al-Fatihah dan doa belajar. Manakala yang bukan beragama Islam, anda bolehlah bertafakur mengikut kepercayaan masing-masing. Al-Fatihah. Amin, amin ya Rabbal Alamin. InsyaAllah apa yang bakal kita pelajari pada malam ini mudah-mudahan dapat membantu anda memahami fizik khususnya tajuk ini dengan lebih baik. Jadi saya tak ingin berbicara dengan lama, cuma saya nak ingatkan kepada penonton semua yang mengikuti kelas kita pada malam ini ya Mr. Peh, kita akan sediakan link e-sijil di akhir siaran nanti. Jadi anda boleh isikan link sijil kemudian dengan menggunakan sebarang domain email. Dan untuk pengetahuan semua, link e-sijil itu akan kita tutup 30 minit selepas tamatnya kelas siaran langsung ini nanti. Jadi anda bukan saja berpeluang untuk belajar sesuatu pada malam ini tapi juga boleh mengumpul koleksi sijil daripada kelas-kelas tuition percuma di Akademi Youtuber. Jadi saya rasa presenter kita pun telah bersedia Mr. Peh. Sega nampaknya di sana bergaya. Sihat ya Mr. Peh?
Ya, sihat.
Okey, jadi tanpa melengahkan masa lagi, saya serahkan kelas kita pada malam ini kepada presenter kita iaitu Mr. Peh yang kini bertugas di Kolej Tingkatan 6 Tun Fatimah Melaka. Okey, silakan Mr. Peh.
Okay, so thank you, Cikgu Hasnitah. So I'm Mr. Peh. As mentioned, I'm currently teaching at Kolej Tingkatan 6 Tun Fatimah Melaka. So as today is Mother's Day, so I would like to take an opportunity to wish my mom, my wife, and also Cikgu Hasnitah and all the mothers in the world happy Mother's Day. So I wish you all stay healthy and happy always. Okay, so without further ado, okay, so actually we are continue our second lesson of Form 5 today's. Okay, so our subtopic today's will be the 1.2 resolution of forces. Okay, so in this subtopic, we are going to learn 2 learning standards, and more of the example question we are going to discuss today will be calculation. So prepare your calculator for our class today. So this is a first learning standard. You need to describe the resolution of forces. Okay, so the definition of the resolution of forces will be like this. Okay, so it's a process. Okay, it's a process of resolving a single force into components. So from the subtopics of 1.1, you learned already. So the few forces you need to combine, where we know as a resultant force in single force. In this subtopic, you are going to separate or resolving a here we have an example. So a boy is pushing his brother, okay, his brother on the pin. Okay, so the pulling force will be mentioned or labeled as a red arrow. Okay, so the force can be resolved into two components. So where particular to each other. So here we have the horizontal component together with the vertical component. So we Fx here showing the horizontal component. Then the Fy label here we know as a vertical component. Okay, so you can illustrate the diagram to this diagram. Okay, so the F here is the pulling force, and then the Fx will be the horizontal component, and then the Fy here will be the vertical component. The angle here will be like this. Okay, so when we moving the Fy to these parts, you can see here will be the right angle triangle. Okay, so you can using trigonometry to relate the Fx and Fy here. Okay, so from relationship between the F and Fy, so you can see here, Fy is opposite at the right angle triangle, respective to this angle. Okay, and then the F here will be the hypotenuse. Okay, so we will be using sine theta equal to Fy over F. And the Fy can be calculated by this formula. Okay, so while for the Fx, so the Fx will be the A over H. So it will be adjacent over hypotenuse. So adjacent will be Fx, hypotenuse will be F. So we're using cos theta, and Fx will be equal to F sine theta. Okay, so this is actually very simple to resolve a single force to the another two forces here, which is Fx and Fy. So here, let us discuss together the question. Okay, so find the horizontal component and the vertical component of the force. Okay, so here we have already labeled. Angle here is 50. So here will be the Fx and here will be the Fy. So again, we're using trigonometry to relate the force here, which is in 200 Newton. So we have to find the value of Fx and Fy. Okay, so the horizontal component, Fx here. So here will be the hypotenuse. It will be the adjacent. Here will be the hypotenuse for 200. So we're using cos for the theory of mathematics, trigonometry. Okay, so the Fx, where we want to find the value, will be adjacent to the angle of 50. Okay, then F will be 200. The angle will be 50. So we just substitute to this equation. So we get Fx will be 200 cos 50. So you'll get 128.6 Newton. So I will show you another component. Here will be the vertical, which is here, Fy. Okay, so the Fy will be here. You can move to here to make it as a right angle triangle. So the Fy here is opposite for the angle of 50. So we're using sine for opposite over hypotenuse. So the Fy will be F times sine theta here. So it will be 200 sine 50. So we get 153.2 Newton. Okay, so the next question. So if you know the answer, you may share answer at the chat room. Okay, so here again, we just reverse the triangle. Okay, so here now, the Fx will be here, label at the left side. If you compare to the question number A here, then the Fy is downward compared to just now when it's forward. But the method using here is also the same. Okay, so you can choose this triangle as a right angle you want to refer to. Okay, so again, you can label the Fx to here. The Fy will be here. So angle is here. So for the horizontal component, Fx will be the opposite for the angle of 70 here. So this one will be opposite. And then the F given as 75. Okay, so using the formula, opposite over hypotenuse, so we will get sine equal to Fx over F. So we substitute all the value given in the question. So this will be the 70 for the theta, and then the F at 75. So you'll get 70.48 Newton for this question for the Fx. Then for the Fy, the vertical part, okay, so the vertical part will be here, which is adjacent for the angle of 70. Okay, then here will be the hypotenuse. So we're using cos. So cos theta will be Fy over F. Okay, then substitute F as 75 given by the question, angle as 30 degree. So finally you get 25.65 Newton. So I think this is quite easy question for you to solve the question. Okay, then the C, okay, so C will be a situation. Okay, so a man pulling a luggage with the force of 100 Newton. Okay, and then here we have the angle to the flat surface, which is 50 degree. Okay, so to the edge of the luggage here. So again, we need to find the horizontal component and then the vertical component. So the horizontal component will be here. The vertical component will be here. Okay, so you can make it as a triangle like this. So here will be Fy, here will be Fx, and here will be 100. Angle here will be 50 degree. So for the horizontal component will be the adjacent for angle 50. So we're using cos. Okay, so this will be the answer. Okay, as I showed you just now. So we need to resolve the force of 100 to horizontal and vertical, which is Fx and Fy. So you can form a triangle like this, where the angle here is equivalent to 50. The force here will be 100 Newton. Okay. Okay, so the horizontal component, Fx will be adjacent to the angle of 50. So the given hypotenuse force will be 100. So we just substitute F as 100, angle as 50. So you may get Fx is equal to 64.28 Newton. Okay, it's quite straightforward actually. Then for the vertical parts will be the same. The vertical parts will be F y, which is opposite to the angle of 50. Okay, so here opposite we're using sine theta. Okay, so again we substitute F as 100 Newton, angle with 50 degree. So substitute to the formula, you get the answer is 76.60 Newton. Okay, so this will be how we resolve the single force to horizontal component and vertical component. Okay, so the question here is one of the objective question related to the learning center 1. Okay, so let's read the question together. Okay, so diagram shows a person applying a force. So the force will be here, 15 Newton, to cut an apple. Okay, so you can see the angle will be 60 degree. So calculate the vertical component, Fy and Fx. So here we need to resolve the single force, which is 15 Newton here, okay, to Fy and Fx. So this is a single force. When we resolve, the Fx will be here, Fy will be here. Okay, again, we can form a right angle triangle. Okay, so here will be Fx, here will be Fy, here will be 60, and here will be F. Okay, so for Fx, which will be opposite for angle 60. So when opposite, we're using sine. So we sine 60 equal to Fx over F, which is 15. So Fx will be 15 sine 60. Okay, then for Fy will be here, which is adjacent for angle 60. So the cos 60 will be equal to Fy over 15. So Fy will be 15 cos 60. Okay, so this will, when you press calculator, you may get your answer already. Okay, so you can look at the step I showing here. Okay, so as I mentioned, here will be the opposite when you already form the triangle, right? Just I showed already, will be here. Opposite for the angle of 60 here. Here will be 15. Okay, so that you get. Okay, so here I'm showing the Fy first. So the Fy will be adjacent. So it will be cos. Okay, it will be cos because of adjacent over hypotenuse. So we get the answer as 7.5 Newton. So which will be actually here, B. Okay, then for Fx will be sine because of the opposite of the angle of 60. Okay, so we get 12.99. So the answer here very clear will be B lah. Okay. Okay, so very fast we go to the Learning Center 2 already. So where we are going to solve the problem involving resultant force and resolution of forces. So the resultant force you actually already learned at the subtopic 1.1. Okay, so we'll be applying F equal to MR for the problem solving later on, together with the resolution of forces where you learn just now at Learning Center 1.1. Okay, so here you will see two types of questions. So first type problem solving is involving in the horizontal plane. Okay, it will be like this. Then after that, we'll continue problem solving related to inclined plane. Okay, so there will be two types of problem solving you will see in the Learning Center 2. Okay, so let us discuss about the first type of problem solving, which is the problem solving involving the horizontal plane. So here is actually plane. Okay, horizontal plane. Okay, so for horizontal plane, you will see two types of cases here. So one will be the pushing case, and another one will be the pulling action here. Okay, so what's the difference here? you can see for the first figure, which is related to pushing force, you can see the force is applying downward to the ground, as I show the arrow, red arrow in the picture. Okay, so here we need to resolve the single force to horizontal and vertical, as we learned in the Learning Center 1 already. Okay, so it'll be like this. So here you can see the Fx direction is forward. Okay, when in pushing case lah, then the Fy is downward. Okay, so you'll be get this diagram again as what you learned in Learning Center 1 already. Okay, so here will be the angle if following this diagram. Okay. Okay, so after we resolve the force, you may get the Fx here will be adjacent to the angle theta. Here will be Fx. Here will be Fy. So I using this triangle for resolution for the single force here. Okay, so as I mentioned, when here is adjacent to the angle theta, okay, so we're using cos theta. So we get F cos theta to right or forward lah. Okay, then for Fy, you may see the arrow is downward. So Fy is opposite to angle of theta here. So it will be sine theta and downward. So the direction will be very important for the problem solving. Okay, so the sign will be using positive or negative for different direction. Okay, so besides that, the force applied in the diagram is also together with weight. And then the F out here will be the frictional force. Okay, so here, the net force, which is applied downward, will be increases. Okay, why? Because you can see the blue color arrow, which is W weight here, have the same direction with Fy. So the effect for pushing, so the main effects will be causes the downward force increases. Okay, so because the Fy and W is at the same direction. Okay, so why you want to discuss this? So at the end of the question will be one of the question for section B. So I will show you the theory behind this problem solving involving for horizontal plane here. Okay, then another case here will be the pulling. So when for pulling, so you can see the arrow is upward. So after resolution, so you can see here, the Fx showing same direction, which is to the right or forward. The main difference here between pushing and pulling here will be the downward force will be different. So here the Fy showing upward. Okay, so here you after resolution, you may see that. Okay, so here the Fx is also showing the cos theta if I using this triangle. And here. Oh, wait, how to see? Here will be Fx. Okay, I using this triangle. Okay, so Fx will be here, Fy will be here. So the Fx here is adjacent to angle theta, so I'm using cos. Okay, then the Fy is opposite to this angle, so I'm using cos lah. So which is outward. Okay, so you can see the main difference here will be at the Fy. Okay, so the effect Okay, so again here will be have another force apply on the wheelbarrow here will be the W weight, and the FR will be frictional force, which will be always opposites the motion. So the motion for both case here will be forward lah. Okay, so the effect here, you may see the net of the downward force will be decreases because of the Fy and W adding at the opposite direction. Okay, so this is an idea I want to bring to you when you see the different situation which is pushing and pulling to the object. Okay, so the downward force will be actually have different effects. Okay, so here let us discuss one of the example you may find at the textbook, page number 15. Okay, so let's read the question together. So figure shows a wooden block being pulled by a force T here, will be here. Okay, so it will be pulling. Okay, that incline at the angle of 30. So the angle given will be 30. So above the horizontal surface will be this surface. Okay, so the table 1.5 shows the magnitude of the forces setting on the block. So we have T equal to 36 Newton, the weight 24 Newton, normal reaction 6 Newton, and the frictional force is 20 Newton. Okay, so the question A asks you to calculate the horizontal component Fx and Fy to pulling. So that means here, okay, so we want to resolve T to two components. Okay, so here will be Fx, here will be Fy. Okay, so you need to draw a right angle triangle here. Here will be Fy, here will be Fx. So triangle will be almost like this. Here will be T, 36 Newton. Okay, here will be Fy, here will be Fx. So the question asking you to find the value of Fx and Fy, where you learned already at Learning Center 1. Okay, so the Fx will be adjacent to the angle 30. Okay, so that means here will be using cos. So the Fx will be equivalent to 36 cos 30. Fy is opposite to the angle 30. So the Fy will be 36 sine 30. So you may get your answer already. Okay, so here you may see the step I already prepared for you. Okay, so this will be what I mentioned just now. You need to find Fx and Fy. Okay, so here Fx will be cos, as I show you the triangle just now. Angle 30 is here. Fx will be here. So which is adjacent to angle 30. When adjacent, we're using cos. So we substitute angle as 30 degree, T equivalent to 36, which is given by the question. So you get will be 36.18 to the right. Okay, and then the Fy will be here, which is opposite to the angle 30. Okay, so here opposite will be sine theta. So formula will be this. Sine theta equal to Fy over T. Okay, then substitute to the formula. Okay, you may get that the value will be 18.00 Newton. And direction is showing outward. Okay, so this will be the example question for A. Okay, and then the next here will be B. Okay, so the question asking you to determine the magnitude and direction of the resultant force setting on the block. Okay, so here will be the learning standard 2, where asking you to find the magnitude and direction of the resultant force. Okay, so here Fx and Fy we get the value already. Okay, so where we get at A. So now we want to see the resultant force for the vertical component and resultant force for the horizontal component. Okay, so here will be the resultant force for the horizontal component. So for horizontal component, you look at the Fx and Fr. Both are in horizontal component. So resultant force, we need to addition to all the forces here. So the 36A. So the Fx is get from A with a value of 31.18. Resultant force will be 20. So I put negative as the direction is to the left. The positive direction I given here is to the right, which is the Fx here. So when we add on, so we get positive 11.18. So showing that the resultant force for the horizontal component will be 11.18 to the right, or to forward also can. Okay, so how about for the vertical component? Okay, so for vertical component, you need to referring to up and down, upward and downward. So the upward force here we have 2, which is 1 R normal reaction, 2 will be Fy, and then downward direction we have weight. So again, you see the value already given for R and W in the question. Fy we get from the answer in A. Okay, so resultant force, that means we need to add on all the vertical component. So again, positive direction for here will be positive, and will be upward, which is 18, Fy and R. Negative here will be the weight, which is showing downward. Okay, so we get here is 0. So we are very clear that when the object is moving in the horizontal plane, okay, so you may look at the resultant force for horizontal component only actually. Okay, so here we get the resultant force of the block is actually 11.18 to the right. So it'll be here. Okay, so this is a example question in the textbook. Okay, so the question C asks you to find the acceleration of the block. Okay, so you learned already at section 1.1. Okay, so when there is the acceleration, or here when there is the resultant force, the object will be accelerated by using the formula F equal to ma, where you actually learn also at the Form 4, Chapter 2, Force and Motion 1. Okay, so the formula F equal to ma will be applied. So the direction moving will be forward with A as the acceleration. We need to find out the value. Okay, so here just now we get ready. F equal to ma. The F here will be the resultant force, where we'll get at B already. So which is equivalent to 11.18 Newton. Okay, and then the mass given by the question here is 2.4. So we just substitute to F equal to ma. F 11.18, M 2.4. You rearrange, you get the answer will be 4.66 meter per second square. Okay, will be this. Okay, show your answer in minimum 2 decimal places and correct unit. Okay, so this is an example question you learned already in your textbook actually, page number 15. Okay, so here let us test yourself whether you understand what we learned just now for learning standard 2 in the case 1, which is in horizontal plane. Okay, so here diagram shows a man is pushing a road mover So with this. Okay, so here will be pushing force, right? Where we learned already just now, where we have two cases, pulling and pushing. This will be push. Okay, so the question asking you to find the vertical forces. Okay, so for vertical forces, you need to focus for upward and downward force only. No need to look at the forward or backward force. Okay, so first, this is a pushing force for the man with magnitude 80. Okay, here, after we resolve, we get Fx and Fy. Okay, so as mentioned, we just need to look at the upward and downward force. So here we only have downward force, which is weight 400 Newton together with Fy. Okay, so you can form a triangle like this. Okay, so here will be Fx. Okay, here will be Fy. Here will be 80. This will be the angle 50. So here, Y will be opposite to the angle of 50 here. Okay, so we're using sine theta here. That means, so it'll be 80 sine 50 for Fy. Okay. Okay, so, or you can using another triangle also can. So that means if I say I show you this triangle, so actually you will get the same. This is a Fx. This will be Fy. Actually, here will be 40. Here will be 40, so it'll be different. Okay, but here the answer all is in 50. Okay, so we should use 50 lah. Okay, we should use 50. Okay, so here, wait, let me check again. Okay, so here 50, you want to get Fy. All is 50, right? 50. So here will be 80. Fy will be here. Actually, is sine, I think, right? I think it's sine theta. Okay, it will be sine theta, and then
Yes,
right is correct, sine. Okay, so here will be W. Okay, so you can see here when two force is downward, you can just add on 400 Newton plus 80 Newton sine 50. Hey, sorry, I think it's correct. It's cos.
and
Okay.
the angle is there, so it should be cos, Mr. Peh. Sorry, yeah.
Yeah, it's cos because
Yeah.
I thought the 50 is here. Actually, it's here.
That one is 40.
Yes.
Okay.
So that means So that means here is actually we're using Z.
Yep.
Okay, so here will be 50. So that means the
50,
answer is
correct.
cos. Okay,
Cos
so I
theta.
show. Okay, I show again. The 50 will be here. Okay, so the Fx will be here. Fy will be here. And this will be 80. Okay, so you can see we want to find the downward force, which is Fy only. So the Fy will be cos. So that means cos is correct. So here will be F, it will be 80, angle will be 50. So we get 80 cos 50. So answer should be A. Okay. Okay, so here we're using W together with Fy cos theta. Okay, so here we get 400 plus 80 Newton cos 50. So downward force supposed to be negative, but both negative become positive because they are same direction. Okay, so answer is D lah. Okay. Okay, and then the next question, number 4. Okay, so here will be the pushing already. Pulling also. Sorry, just now is push. This one is pulling. Just now the case will be push. Here will be pull. Okay, so diagram show a load pulled by a man. So the load will be with mass 12.0 kg. So what is the resultant force? Cause the load to move in horizontal direction. So that means we just want to look at left and right, or forward or backward only. We not need to look at the downward or upward force. Okay, so horizontal direction. Okay, so that means we want to look at forward and backward force only lah. Okay, so here the backward force will be frictional force. And then here we need to resolve this single force, which is 40 Newton. Okay, so here after resolve you get Fy and Fx, but we just need to know the value of Fx. Since the question just asked about horizontal force for horizontal direction. Okay, so we don't need to know the Fy. Okay, so again you form a triangle. Okay, so here will be 30, here will be 40. So the Fx will be here. So together with the angle of 30, so it means this is adjacent. So we're using cos lah. So which is 40 cos 30 lah. Okay. So adjacent, opposite. Okay, so we just need to use Fr and Fx. Okay, so the answer I already prepared, which is 40 cos theta, since this is adjacent. So, and here you can see they are in opposite direction. So you need to minus lah. So Fx plus Fr. So Fr is in opposite direction. So we need to minus here. So you get 19.64. So answer is A. So actually it's quite easy now for this subtopic. Okay, and then question number 5. Okay, so here the question showing a man is pulling a load again with different angle 60 and 30 Newton. Now the question asking you to find the acceleration. Okay, so the acceleration will be forward. So that means we also just need to know the horizontal component, which is the Fr together with Fx. Okay, we don't need to know the force at the vertical component. Okay, so after we solve, okay, we get, so here the Fx is adjacent to angle 60, so which is cos will be used lah. Okay, so again, moving forward involving horizontal component as I mentioned. Okay, we just take care about the frictional force and the Fx. The Fx will be adjacent to angle of 60. This is Fy lah. If I say this is a triangle. So adjacent we're using cos. Okay, so and these two forces in opposite direction. So you'll be minus lah. 60 cos 30 minus 5 equal to MA. Okay, it will be this. F equal to MA, where we want to use here. So 60 cos Fr minus 5 equal to 4A. So after rearrange, you get it as 2.5 meter per second square. So answer very clear will be C. Okay, so it's not very hard for this subtopic. Okay, and then here we have one example question for section A, paper 2. Okay, so diagram 1.1 shows the truck pulling. Okay, so we're pulling a car that breaks down by using a cable with this. Okay, so the mass of the car will be 600 kg. So what is the means by the weight? So the weight definition you learned already at the subtopic 2.8 from 4. Okay, so which will be the gravitational force acting on the object. Okay, so this is a reference answer for you. Okay, then the B question asking you to find the weight of the car. So the weight will be equivalent to mg, where you learn also at 2.8. So m given as 600 multiply with 9.81. So you get 5,886 Newton. Okay, then C, the question asking you to label the weight of the car. So the car will be here. You just need to draw an arrow to showing the weight, which is added downward lah. So will be this lah. Okay, so this is a reference answer. Okay, then the next here will be the question related to the subtopic we learned today. Okay, so diagram 1.2 shows the cable is at the angle of 40. Be here. To horizontal. Okay, will be this angle actually. So the force F that applied to cable is about 15,000 Newton. Okay, so here the question asks to draw the horizontal component Fx and Fy. So here will be this. You will get 2 marks where you learn already, learning standard 1.1. Okay, Fx will be showing as a horizontal component, and then Fy will be here, vertical component. You can get 2 marks for this question. Okay, and then what is the effects for component Fx and Fy to tow the car? Okay, so we already know how we calculate the Fx and Fy. So what is the Fx and Fy show for this example? So the Fx will be actually the force to pull the car to move forward. Okay, so this is the force you get. It's actually used to pull the car forward. Okay, so how about the Fy you calculate in the case in diagram 1.2? Is actually the force to lift the car upward. Okay, so the question might ask you, what is the meanings by the Fx and Fy you calculate for the certain of the condition? So this is the example question, can let you to refer to. Okay, and then the next question, the question asks you to find the Fx. I think this one should be no problem lah. So the Fx will be here, which is the adjacent to angle of 40. So when adjacent, we will choose cos. So answer very clear with this. Okay, so you just tick your answer. Okay, and then the next question here, name the physics question used to resolve a single force to horizontal and vertical. So this one you learn already in this subtopic, definitely with solution of forces lah. Okay, so this is a reference question you may see at the subtopic 1.2. Okay, so Cikgu Hasnitah, I think we can take a break before we continue.
Okey, boleh. Baiklah, pelajar-pelajar sekalian, kita berehat seketika. Jangan ke mana-mana. Kembali lagi selepas ini. Okey, students, kita kembali lagi bersama dengan kelas secara langsung tuition online percuma bagi subjek Fizik SPM untuk kelas DLP tingkatan 5. Sebelum kita sambung, sekali lagi cikgu nak ingatkan kita akan kongsikan link e-sijil bagi kelas ini di hujung siaran nanti. Anda boleh isikan menggunakan sebarang email, jadi tanpa melengahkan masa, ayo kita sambung semula kelas kita. Silakan Mr. Peh.
Okay, so thank you, Cikgu Hasnitah. Okay, so let us continue the second case. Okay, so problem solving involving the in-kind plan or in-kind plan.
Ya.
And here,
Ya,
okay, so
plan.
yeah.
Ya,
Okay,
no
so here will
problem.
be the yes. Okay, so here will be the figure, which is the in-kind plan showing by the arrow here, with the angle theta here. So object will be here. Okay, so the moving direction, we assume moving downward. Okay, so here you can see when the object moving downward, there will be a frictional force added at the opposite direction, showing in the blue line here, blue arrow here. Okay, so here another force will be added to the object. Here will be W, weight of the object. Okay, so here the question will be asking you to resolve again the single force, which is at the W here. Okay, so the component parallel to inclined plane, WX, will be here actually, showing by this arrow. Okay, so you can see the difference, right? So here we want to see component at parallel to the inclined plane, which is showing by WX here. And then another one will be component perpendicular to the inclined plane, so it will be WY. So that means here we resolve the force, here will be W. Okay, so here the angle theta will be here. Why? Because here will be 90. So here will be the another angle. So after we minus, you may get this angle will be
Theta.
actually theta lah. Okay, so as I mentioned to you just now, this is a theta. Okay, so you may moving 3 force here. W will be here. W will be here, WY will be here, and then WX will be here. So a triangle, right angle triangle will be formed again. So again, you can using trigonometry to relate W with WY and WX also. So for WX component parallel to inclined plane, so definitely we relate to W with WX. So you can see WX will be opposite to the angle. So they will be sine. Okay, so it will be W sine theta. Okay, and WY will be adjacent to angle of theta here. So they will be using cos, which is WY equal to W cos theta. So this is the theory you need to use or apply in your calculation. Okay, so here I will show you one example at your textbook also. Okay, textbook page number 16. Okay, so figure shows a free body diagram of the block sliding down a smooth inclined plane. So this is a block. When here showing the smooth inclined plane, so that means the frictional force will be equal to 0. Okay, so this is what you need to keep in your mind. Okay. Okay, so the question asks you to sketch the component of the weight of the block which is parallel to the inclined plane. So just now I showed you the arrow already. So it's supposed to be here. Be here lah, actually. And then WY will be perpendicular to inclined plane. So this is an inclined plane, perpendicular. This is 90 degree. So here will be WY. Okay, so this is actually the answer lah. Okay, so here will be F. Okay, it will be WX. We just follow the symbol using in the question. So this is WX. Will be parallel to inclined plane. So this is an inclined plane. So both is parallel lah. Okay, so here WY will be perpendicular to inclined plane. So this is an inclined plane. Okay, so this will be the answer for question A. Okay, and then the angle 60 will be here. I showed you just now already how we get that. Okay, then the next here will be determine the resultant force setting on the block. Okay, so here Fx, actually Wx will be W sine theta because of if you're moving the line to here. So it's actually opposite to angle 60. So it'll be sine theta. Okay, so the W given as 24, angle is 60. So we get Fx is actually 20.78. Okay, then the Fy, actually the resultant force will be involve Fx only lah. Okay, just here we want to show you that the Fy will be not affected, which will be have a net force of 0. Okay, so here we substitute W cos theta because the angle Fy is adjacent to 60 degree. So we get 12. So here you can see Fy 12, normal reaction is also 12. So that means here there will be not affecting the resultant force for the overall reaction here. Okay, so you can see the resultant force added perpendicular to inclined plane will be 0, which is normal 12 minus the Fy, which is 0. So that means the resultant force will be only involving parallel to inclined plane. Okay, because the object here, the block here will be moving along the inclined plane only. Okay, so here resultant force parallel to inclined plane will be involving Fx only, as the frictional force here is 0. So answer 20.78 Newton downward. Okay, so the Fr 0 because the question given us the condition for inclined plane is smooth. Okay, then the C, calculate the acceleration of the block if its mass is 2.4 kg. So here we applying the formula F equal to ma. So A, what is the value we want to find for this example, this question? So question given us F will be 20.78. So we substitute in the formula F equal to ma. So where F equal to 20.78, A will be 2.4. So and now we get the value of A will be 8.66 meter per second square. Okay, so this is an example question you may find in the textbook. Okay, so here let us solve the question number 7. Okay, so here diagram 8 shows the box wedging of 20 Newton resting on the inclined plane. Okay, so resting, that means here there will be no moving. Okay, so the force acting on the box will be equilibrium. Okay, so here there will be F2 and F3 involved only, since the object will be moving parallel to inclined plane. Okay, so and then the F2 and F3 will be the same. This will cause the object stay rest on the inclined plane. Okay, so here angle will be 50, weight 20 given by question. Okay, so here will be sine as parallel to inclined plane will be here, which is opposite to angle 50. So the F3 will be 20 sine 50. Okay, so for F2, they will be same, so that the object will be stay rest on the inclined plane. So answer here, a very clear will be B. Okay, so equilibrium. So F2 will be equal to F3. So F3 20 sine 50 as I showed you just now. So answer here will be B lah. Okay. Okay, and then here we go to our last question, question number 8. So this will be the sample question for section B. SPM question 2011, I think. Okay, so diagram 11 shows the boy with a mass of 40 kg sliding in two identical flumes. Okay, so one after another. Okay, so WC here will be component or weight parallel to slope. Okay, so for the A, what is the meanings of frictional force? Okay, so here frictional force is actually showing with the value of 120, which is opposes the motion. Okay, so here is a reference answer for the definition. Is a force acting against the applied force. So applied force here will be WC, which is moving downward. Okay, so here question B. Okay, so question B, based on diagram 11A, here, you need to calculate the component of weight parallel to the slope. So we have to find the value of WC. Okay, WC will be here. So here, just now you learned already. Okay, so here will be angle of 30. Okay, so here the WC will be opposite to the angle of 30. So it will be sine. So you get mg sine theta, m given as 40, given by question. Okay, G will be 9.81. Okay, 9.81. Theta will be 30. So we substitute the angle, the value to formula. So you get 196.2 Newton. Okay, then the second question asks you to find the resultant force on the boy. So the resultant force involved will be parallel to inclined plane, which is WC and 120, which is the frictional force. Okay, so here we're using WC minus 120. Okay, so here, as I mentioned just now, resultant force will be involving the forces parallel to inclined plane, which is WC and frictional force only lah. So we don't need to care about R and also the perpendicular component to the weight. Okay, so here 196.2 minus 120, so we get 76.2. So that means the boy will be moving downward lah, because the WC is greater than the frictional force. Okay, then here acceleration. Okay, so since here we have the resultant force, definitely we will have the acceleration. Again, we're using the formula you learned already at the field example just now I show you, which is F equal to ma. So the A will be moving downward, and as I mentioned just now, so we substitute resultant force as 76.2, and then M given as 40. So substitute everything to the formula. So rearrange, you get your answer. Here will be exactly 1.905 meter per second square. Okay, so this will be the answer. 2 marks. First mark will be given for substitution. Second marks will be given for minimum 2 decimal places with correct unit. Okay. Okay, and then the next here will be the theory, 4 marks. Okay, the question will be like this. Okay, so using the concept of force, explain why the boy slide down in the flume when the angle of inclination is 30. Okay, so the 30, we just not already calculate the resultant force will be moving downward with 76.2 Newton. Okay, so why the boy or the boy here will be stationary or stare rest when the angle decreases to 17.5 degree. Okay, so that means here we want to find whether the resultant force WC minus 120, we have the positive value. So if WC is less than the frictional force, that means the downward force is not able to overcome the friction. So the man or the boy here will be stay rest on the from here. Okay, so just now for the case A, we get ready. WC is 196.2. Then the frictional force given as 120. So the frictional force is less than WC, where we get the resultant force is 76.2. Causes a boy moving downward. Okay, so now we need to calculate the WC value, whether it's greater than frictional force or not. So from the statement here showing that remain the same, so we expected WC will be less than 120. Okay, so here again we're using the same formula, mg sine theta. Okay, so mg sine theta, so the theta here will be changed to 17.5. So we get 118 Newton, which is slightly less than the friction. So that means we're very clear that this is why the boy will be stay rest on the room. So because of the WC is not able to overcome the frictions. Okay, so here what is the 4 marks suggestion answer? So here will be first the boy side downward at angle of 30. Okay, because the component of barrel, which is WC here, is greater. So this is WC. You can just given WC. So because WC is greater than the frictional force. Okay, so you can using WC to instead of the component force barrel to slope. Okay, then this is the first discussion why at 30 degree the boy can be moving downward. Okay, so this is because the forces are not in equilibrium, in which the resultant force is not a zero. Here, just now we get already, the value will be 36.2, where you can get by 196.2 minus 120. Okay, then therefore the boy will be accelerated downward. Okay, so the mark number 4 here will be explain about why the boy not able to moving down or stay rest when the angle is 17.5. Okay, so just now I show you already, because WC value is less than 120. So the reference answer here will be the boy stays stationary at angle of inclination 17.5 degree. Okay, because the WC is smaller than the frictional force. Okay, so this is a right answer for this question. Okay, so 4 marks, you need to give at least 4 points. Okay, so here will be the last discussion. 10 marks question for section B. Okay, so you need to select the most suitable remover to cut the glass efficiently. Okay, so here we have J, K, L, and M here. So here you need to discuss 4 characteristics. Okay, so where actually is not stated directly in this question. Okay, so firstly, what you can discuss, you need to observe the different characteristics among these 4 wrong mover. Okay, so we advise students give the answer in table form. Okay, so the first you can see the method is different. One is a push, another one will be pull, where actually I emphasized already at the beginning of the learning standard 2 here. Okay, I given 2 cases for the horizontal plane, right? Okay, so here, pushing and pulling will be showing different for the downward force, where we discussed already just now. Okay, so here the method, which one we need to use. So for glass efficiently, cut the glass efficiently, that means we need to have the greater force added downward, which will cause the blade here more near to the glass. Okay, so here again, if you forget, you can just show in your arrow and resolve again, so you can see it is very clear that the push will be showing downward force. And then for the for the pulling, so after resolve, you get actually Fy is in upward, so which will be opposite direction to weight. So here will be decreases, this will be decreases the downward force. So we preferable the push method, which will be given greater downward force to the glass lah. So here we are using push method, as I mentioned just now, because of the Fy showing downward together with weight of the roll mover. So here will be providing greater downward force to the glass, so that the this cut method will be more efficiently lah. And then the K and L will be wrong already lah. Okay, so we left J and M. Okay, so the second, what is a character we need to discuss. So you can see here we have the mass different. And then we have the size of the cutter is different. And then we have the angle is different. So that means we have total 4 character can be discussed. So next here we discuss the mass. So again, you can see mass will be 5 kg and 10. So mass will be related to stability and together with weight of the object. So here actually can have 2 different reasons here. So we preferring to have the greater mass because it will be providing more stability. Okay, so the mass will be bigger or larger. So because it will be more stable. Or actually you can given the answer same as the first reason, because you want to have the greater downward force applied on the glass is also accepted. Okay, so here we can give the same reason as the first here. Okay, then the next. Okay, so here very clear, 5 kg will be wrong already. So we left M. So the answer is very clear. We want to have the bigger angle, right? Here will be 35, another will be 20. So we want to have bigger angle and also bigger size of the cut blade. So definitely we can get at least 8 marks already lah. Okay, so here we choose M, right? Okay, so here size of the cutter blade must be big lah. Okay, so that we can cut more glass. So here more glass can be cut. And then the last here, the angle must be greater. Okay, so angle must be greater. Again, will be causes the downward force become greater. Okay, because here the angle will be sine. The greater sine angle will be given greater value. So that means bigger angle will be have greater force produced lah. So this will be the answer actually same as the first one lah. So that means actually reason for the first one, mark number 2, mark number 4, and mark number 8 actually can given with the same reason. Okay, so here we choose M. Then we copy all the aspect, which is push method, large mass, bigger cutter, and bigger angle. So you'll get full marks for this question. Okay, so that's all for my sharing today. So I pass back to moderator, Cikgu Hasnitah.
Okay, thank you very much Mr. Peh. Terima kasih. It's a very vivid and clear explanation together with a good example. Jadi terima kasih juga kepada semua yang telah bersama dengan kita pada malam ini sehinggalah ke saat ini. Jadi diharap anda dapatlah pelajari sesuatu ataupun menggunakan peluang pada malam ini untuk mengulang kaji sebagai persediaan peperiksaan yang akan datang khususnya bagi pelajar-pelajar tingkatan 5. Jadi seperti yang Cikgu janjikan tadi, kita akan kongsikan link e-sijil. Sekarang anda boleh lihat di paparan skrin. Itu dia linknya, anda boleh isikan dalam tempoh 30 minit selepas kita tamat bersiaran nanti dan anda boleh menggunakan sebarang email untuk mengisi sijil ini. Jadi jangan lupa bersama-sama lagi kami pada minggu hadapan. Kita ada 2 kelas lagi iaitu pada hari Jumaat. Kelas untuk tingkatan 4 akan disampaikan oleh teacher SlindaNordin dengan tajuk dia 1.2 penyiasatan saintifik. Waktunya Jumaat 9.30 malam. Dan satu lagi kita ada kelas tingkatan 5 seperti pada malam ini iaitu akan disampaikan oleh saya sendiri Cikgu Hasnitah dengan tajuk yang seterusnya 1.3 Forces in Equilibrium. Jadi itu adalah waktu siaran kita untuk tahun ini. Jumaat saya ulang 9.30 malam untuk tingkatan 4 dan Ahad 8.45 malam untuk tingkatan 5. Jadi anda jangan lupa subscribe channel presenter kita pada malam ini. Boleh tekan butang subscribe di bawah dan like juga pada siaran ini supaya anda tidak ketinggalan untuk mengikuti kelas-kelas ataupun video-video yang di-upload oleh Mr. Peh. Anda akan mendapat notifikasinya. Jadi subscribe juga channel cikgu-cikgu kita yang lain di Panitia Fizik SPM. Semoga apa yang kami bawakan memberi manfaat kepada semua. Jadi Mr. Peh, ada pesanan terakhir barangkali malam ini sebelum kita melabuhkan tirai?
Itulah kita harap pelajar boleh sharekan link kelas kita supaya lebih ramai boleh manfaat daripada kelas yang dianjurkan oleh IU Physics ini. Okay, itu sahaja daripada saya.
Okey. Sekali lagi saya ingin mengambil kesempatan untuk mengucapkan selamat Hari Ibu. Yang pertama kepada mak saya yang tercinta, Mariam binti Tamu, kepada mak mentua saya, Salam binti Mak Isa, dan begitu juga kepada semua guru-guru di luar sana yang juga merupakan ibu anda adalah seorang insan yang hebat dan bakal melahirkan hero-hero yang berjaya lah kita harapkan. Begitu juga dengan pelajar-pelajar, anda bolehlah ucapkan selamat Hari Ibu kepada ibu masing-masing. Tunjukkanlah kasih sayang anda dengan cara belajar bersungguh-sungguh, menjadi anak yang baik dan rajin dan sebagainya. Jadi kami doakan anda menjadi insan yang berjaya dan insan yang berguna di masa akan datang yang boleh dibanggakan oleh negara kita Malaysia khususnya. Jadi sekian dulu daripada kami. Semoga kita berjumpa lagi di waktu dan siaran yang akan datang. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera, selamat malam dan jumpa lagi. Bye-bye semua.